Hello everyone, very good evening. All right everyone, so we are good to start now. So like as discussed in the last class, we are going to start today with your IPv6. So first of all, I'm going to give you some introduction about IPv6 as it's really very much important, or we can say it's a very crucial part to understand the NRC effectively, because NRC is basically almost a lot of things we are going to deal with IPv6. So that is one thing that I'm starting with IPv6 intro part. Then we'll try to see some lab sections. So I'll be writing the heading as Introduction to IPv6. Now, in this introduction, which is for your IPv6, we are going to see, there are two versions of IP, and IPv6 is very much an advanced version of IP, which was released after IPv4. So whenever I say IP and versions of IP address, so basically there are two versions of IP address. I'll write here. Two versions of IP. So the two versions we got is like the very first version of IP, or I'll just create a table for that to make you understand in a better way. So I'll just simply say the versions, and there are two versions which we got in case of Internet Protocol. We have IPv4 and we have the advanced version to which we call as IPv6. So these are the two versions of Internet Protocol which we do usually see, and basically in your CCNA trainings and your ENCODE trainings. So we have almost discussed the IPv4 version, and whenever we say IPv4, so this IPv4 is basically of 32 bits. So I'll say here that this v4 is consist of 32 bits, and it is usually written in the form of decimals. So the notation we use is decimals. And when we talk about IPv6, it's a 128-bit address, which is written in the form of hexadecimal. So these are few things which we usually discuss, but mainly if you will see as in like comparison with v4 and v6. So v6 is pretty much very much advanced version. And what is the main reason for IPv6, or can we still rely on IPv4 address? Like if you will see, many production environments are still using IPv4 address, but do you think that is it the right time to still rely on IPv4 address? So it's practically it's not the relevant answer that you cannot rely on IPv4 address, because if you will see many telecom operators like Jio, Vodafone, Airtel, they started using IPv6 addresses. Like if you will search what is my IP on the public IPs you are going to search, so you maybe find some IPv6 address as well in case of your public IP. But the main reason behind the release of IPv6 was that this IPv4 address was having the total space of 4.3 billion addresses.
If you enjoyed the content of the video, don't forget to like and share the video and subscribe to our channel.
So this is the total address space which was available in case of IPv4. Whereas when it comes to IPv6, it's a 128-bit address. So you're gonna simply say 2 raised to power 128, which is going to give you some addresses in trillions, where every single human on the planet can have one single IP and still will not run out of the IP addresses. But after before launching IPv6, there were few possible solutions which were launched, or we can say which were announced after IPv4. So after IPv4, there was something we call it as network address translation and a concept of subnetting. These two possible solutions were also introduced just to overcome the shortage and the exhaustion of IPv4 addresses. But still, we were not able to, rely on IPv4 addresses because the network was rapidly growing and the need for IP address was also increasing. So that's why we came up with this IPv6, and this IPv6 was announced in somewhere around June 1999. And now it's really mandatory for each and every device. Either it is your device or it is your iOS. Doesn't matter which iOS you are using, like it may be Linux iOS or it may be Cisco iOS. Every iOS has the built-in support of IPv6 address, that it has to support the IPv6 features. So it's now mandatory with each and every of iOS which is coming up in the market that it should be having the IPv6 capability and it should support all the features of IPv6. Now, before going towards the IPv6, let's have a quick comparison between v4 and v6, where I'll be talking more in detail about the features of IPv6. So let me write down here. So I'll say features of IPv6. So the very first feature of IPv6 is that, this IPv6 is an extension of IP with several advanced features. And we usually know that v6 is a very advanced version of the Internet Protocol. So we do have a large address space. This is the first point we can say. Large address space. So when I say large address space, which means that in case of IPv6, we have a very large address space, which simply means that when you will say 2 raised to power 128, it's going to give you addresses in trillions, which means that every single person can have one single IP over the internet and still won't be able to run out of the IPv6 addresses. So this is one thing about the IPv6, that we do have a very large address space. The second thing, no network address translation is there. So I'll mention no need of network address translation. So this network address translation, like up to I'm saying here, it is something like, right now it's not required in case of IPv6, but we cannot say about the upcoming years, like, what happens after 50 to 20 years, that if in case we will be running out of IPv6 as well. So maybe network address translation for IPv6 can be introduced. But as of now, it's not required up to 10, 20, 30 years that we don't need the network address translation. Also, no more broadcast here. So it's not going to use any kind of broadcast. And also it supports auto stateless configurations. So I'll say supports auto stateless configurations. So auto stateless configuration means that a device can have an IPv6 address by including its own MAC address. So this point I will explain you separately when we will see the NDP process and all these things to figure out how linked local address and all these things are going to work. And also in case of IPv6, we have some inbuilt security. So when I say inbuilt security, we do have some IPsec features which are pre-enabled in case of IPv6. And also we have the capability to have multiple addresses per interface. So I'll write this point, capability to have multiple addresses per interface. Now see guys, this thing is also possible in case of IPv4 address, that we can use multiple addresses per interface. Like let me show you if it is possible on packet tracer. What exactly I'm referring here. Raghu, you're trying to say something. I'm not able to hear you.
It's okay now. Fine.
Yes, yes, you're audible now. So, like, see, guys, here this is a router which I'm taking on the packet tracer, and just something I want to show you. So, I'm gonna use one command, enable, and let's verify show IP interface brief. And as you can see here, that I got three interfaces: gig 00, 01, 02. So, I'll be going on the global configuration mode, and I'm going to select interface gig 0/0, and I'll say IP address 192.168.1.100/24, no shutdown, exit, and if you'll verify, do show IP interface brief. So as you can see that I have assigned one IP 1.100 on the gig Ethernet 00. Whereas if I'm going to select the interface once again gig 00, and I will say instead of 1.100, I'll say 1.150. And I'll verify you now, do show IP interface brief. So you can see the IP is replaced. Previously I was having some 1.100, now I'm getting some 1.150 IP address. So also, what you can do is in case of IPv4 address, if you'll put question mark here, Alright, it's not supported here on the packet tracer. So just let me show you on the lab screen. So I'm going to open my EVNG. So just allow me for a sec and then I'll show you. So let's say that I'm gonna turn on my router. This command is not supported on packet tracer, so we'll see on the lab screen. So let this device turn on first, and then we'll see what exactly this point I was referring, that capability to have multiple addresses per interface. But meanwhile, this device is about to start, guys. See what exactly this point was, like the last point which I have written on the slide, that capability to have multiple addresses per interface. So by this point, what exactly I'm referring is, let's say you got one device, or let's say this is your router. This router is having this particular interface 0/1, and on this 0/1 you can define one IP. Let's say you have defined 10.0.0.1. Also you can define 10.0.0.2, and you can mark this IP as a secondary IP. So this scenario is possible in IPv4 as well. But why I'm mentioning this point, that capability to have multiple addresses per interface, because in case of IPv6, on one single interface, you can assign public IP as well as you can assign private IP also. But in case of IPv4 address, you are only allowed to use the private IP. You aren't allowed to use the public IP on the single interface. Let's try to see here so that your doubt will also get clear. All right, our device has now started and will verify show IP interface brief. So as you can see, the gig 00 is unassigned. All the interfaces are unassigned. So we'll quickly go on the global configuration. So the device is like started. So I'll select the interface. Gig 0/1 or any interface you can select gig 00. I'll say IP address 192.168.1.100/24. And if I will put question mark here, you can see you are getting one option secondary. So make this IP as a secondary address. So you can use this as secondary IP. And the first IP, let's say that you are going to use this as the IP, and let's say 1.150. And when you are going to add this keyword secondary, so over here, the secondary IP is also added here. So this is the primary IP which you have given to this interface, and this is the secondary IP. But in case of IPv4, this is something which is basically used in FHRP scenarios, like when you are having some first hop redundancy scenarios. But if you'll try to see, you'll only get the primary IP. So if you'll see show IP interface brief, so you can see you're only getting the primary IP. But if in case the primary fails, then the secondary will come up. But this was the point which I was about to mention over here. So let me just close this device. And here, like you can see, in case of IPv6, I'm mentioning that capability to have multiple addresses per interface, where you can define private and you can also define the public IP. So these two IP addresses on one single interface you can define in case of your IPv6. And this point, the third last point, that supports auto stateless configurations. It is something related to your, we can say, some of your link local address, which separately I'll explain you. So this is one thing. And now let's try to see how basically the IPv6 structure looks like. So let's have a look at v6 structure and how we'll define this. So I'll write the heading as IPv6 structure. So we know that v6 is all about, like, we can say it's an address which consists of total 128 bits. So we'll try to see how it exactly looks like and how we are going to define it. So let's take one example. So I'm going to write one address. Let's say I'm going to write 2001 and it is separated by a colon. So I'm going to use 1, 2, 3, 4 zeros here. 1, 2, 3, 4. Again, I'll write colon and I'll write 1, 2, 3, 4. Colon and let's say 0, 0, 2, 0, colon 1, 2, 3, 4. 1, 2, 3, 4. and I'll define some other values, let's say 4CD4. So this is how exactly the IPv6 structure looks like. Now in this IPv6 structure, it's a total 128-bit address which is written in the hexadecimal format, where each portion, like this 2001, the single 2001 represents that it consists of total 16 bits. And in this 16 bits of the portion, I'm erasing this point and I'm separately creating one more octet for this to make you explain in a better way. So I will say this 2001, this entire portion is consist of 16 bits. So which means every single bit like 2, 0, this 0 and this 0, it's consist of 4 bits, 4 bits, 4 bits and 4 bits. So that is how it's going to be your 16 bits in total. And we do have total 8 portion where each portion represents 16 bits and one single number represents 4 bits. So in IPv6 guys, apart from this, one more thing you all need to understand. So whenever we define IPv6 structure, we divide the IPv6 into two parts. The first 64 bits we call it as global prefix value, and the last values we call it as the interface ID. Now guys, see, this global prefix value is as such nothing, but by default 64 bits are divided, and it's like something the reservations are there. So the first 64 bits, this global prefix value, we call this global prefix value as like it is similar to the network portion of your IPv4 address. So I'll say network portion, and this interface ID represent it as host portion. So this is something we do have in here, and we know that it's a 128-bit address where like total 8 octets are there, or you can say 8 bytes are there, which consist of total 16 bits in total. Now, the next thing, like, you can make this IPv6 address more shorter by reducing the number of zeros. So I'll write this point here with the red pen. Make IPv6 shorter by reducing the number of zeros. Now, when I say that we can make IPv6 address shorter by reducing the number of zeros, and also we can add double colon, like how we are going to make it more shorter. Like let's say that I got some address. So here reducing the number of zero doesn't mean that this 2001 I'm going to write like 21. It's not accurate. So you need to mention the complete 2001. Now here you can see you got two zeros, like continuous 4 zeros you got. So what you can do is colon single zero, colon single zero. So that's how you can represent four continuous zeros. Like if you got four continuous zeros, it can be represented by 1 0. And again 4 zeros I have represented it with one single zero. Then I got 1 2 3 4. Then again colon, and see here I got 0020. So if I will mention 20, so the machine will automatically understand that previous two digits were 00. Then again 00 are there, so I'll mention 0 0 and 4CD4. So this is one correct way of defining the IPv6 address. The second way, you can make it more shorter, like 2001. Now when you got double colons like second octet and third octet, so what you can do is 2001 colon colon double colon you have to mention. Then you are going to write 1234 colon 20. And now again you got this something like this. So you cannot use double colon twice in the IPv6 address. So instead of that, you are simply going to mention the IP like colon 0 colon 0 4CD4. So this is one way of writing the IPv4 address correctly, and that's how you are going to define the IPv6 address. And this is how like all these things are going to work, which we will see practically more in detail when we will verify the lab scenarios about static OSPF and EIGRP with IPv6. So this is how the IPv6 structure looks like. The next thing we have is the IPv6 address types. Like we do have some IPv6 classes and all these things. So in case of IPv4, we do have some classes A, B, C, D, and E, which were defined by their specific ranges. But in case of IPv6, we do not have the ranges. We basically have the types of addresses. So let's try to see that. So I'll write the heading as IPv6 address types. Types of IPv6 addresses. Now in the types of IPv6 addresses, guys, we got three categories. The very first category of IPv6 address is unicast. The second category is your multicast. And the third category we got is your anycast. Now when it comes to unicast, it is the normal IPv6 which can be defined on any machine or any of the node machine or client machines. Whereas multicast is more similar to class D and anycast is a different from broadcast, but it is quite similar to multicast, but I'll show you that as well. So let's try to get more in detail about each and every of the category. Let's start with unicast first. The first category of IPv6 is unicast IP. So when I say unicast, this unicast IP is something. So this unicast IP is something we can say it's the normal IPv6 address, which can be assigned on any of the device, which can be assigned on devices. So this is one thing. Now inside this category of unicast, we got three different categories. This unicast is divided. So I will mention three categories of unicast. The very first category of unicast address, I'll mention it with a green pen. The first category of unicast, we call it as global unicast. Now, when I say global unicast, what exactly this global unicast is? So this global unicast is more similar to your public IP. So in case of IPv6, when you will find any public IP, so we call the public IP as global unicast IP. Now, how come you are going to identify that this is a global unicast IP? So this global unicast IP, it always starts from 2000 /3. So any IP which is starting from 2000 /3 is represented by the public IP, and the /3 is a reservation which is done by INA, where I'll mention this point as well. So this /3 represent that the first three bits are 001 by INA. So how come we say that the 001 is represented by INA? So we can take one example to understand that. So let's try to understand that I got some IP address here, and the IP address which I got was 2000:/3. So I'll write the heading as this is my public IP or global unicast, we can say, to understand it. And the range which is given for global unicast is 2000:3. Now, if you'll try to see the conversion, convert into binary. Now, when you are going to convert this value into binary, so you see that you got some values like 2, 3 zeros. Now, this 2 represents how many bits? 4 bits. So if you will see the conversion of 2, so to do the conversion, I'll simply mention like this. So we got some values like 8, 4, 2, and 1, because I only got 4 bits to convert. So 8 represents 0, 4 represents 0, 2 represents 1, and 1 represents 0. So 001, this is the /3 notation. And already I told you here that any IP which you see by 001 is reserved by the global unicast IP. Now there is one more statement we can add in here. See, the 001 is constant. But the again, like you can see over here, this 0 is also still remaining. Like many operators are trying to use this concept now that this 0 can be 1. Now, if you will do the conversion, like 001 is constant, but if you will try to convert this value of 1 as well, like there 10 is still pending. So if you will do the conversion, so it is giving you the conversion of 2, it is giving you the conversion of 3. So any address which starts from 2 or 3, you can say like 2000 or 3000. will be considered as your global unicast IP address. So any address which starts with 2000 or 3000 will be considered as your global unicast, which is like basically we can simply say in simple terms that this is the public IP which is like routable and which is basically used over the internet for the communication. So this is what we got in here about the global unicast. Now the second category of unicast address, we call it as unique local. So when I say unique local, this unique local is nothing but this is represented as the private IP of IPv6. And this private IP always starts with FC or FD. FC00 double colon /7 or FD00 double colon /7. So unique local IP starts with FC FD00 colon /7, where /7 are constant bits. /7 is equals to constant as per INA. So this is one thing. Now any address which starts with FC or FD is considered as unique local address. Now how come you are going to see that? If you will see the conversions, so I'm going to write here the conversions. So we got two addresses here to convert. So I got some FC and some FD. So if I'll be converting F and C, so let's try to see for FC. So the conversion for FC will be, yeah, so 8421. So 8 plus 4 2 1. Yep. So the conversion for F will be 1 1 1 1, and the conversion for C will be 8 plus 4 12. So 1 1 0 0. So this will be the conversion for FC. So here you can see the 4, 5, 6, and 7. This /7 portion is specifically reserved for FC. Whereas if you'll try to convert FD, so here like you can see in the conversion of FD, you will be getting some value of 1 1 1 1 for F, and for the conversion of D you are going to get 1 1 0 1. So over here this is the conversion, because the last value can be equivalent, like it can be 0 or it can be 1. Apart from that it will not be any other value. So that's why we say FC or FD. And 0 0 colon colon /7. So this /7 is the representation where these first 7 bits are represented by INA, that these are the reserve bits which we cannot manipulate. This is one thing. And lastly, we have the third category of unicast IP. So I'll write here. The third category, we call it as link local. Now, what exactly this link local IP is? This link local is nothing but this is a default IPv6 address. It's a default IPv6 address enabled on every IPv6 interface, every IPv6 configured interface. So this is one thing about the link local address, and the range starts from FE80, starts from FE80 double colon /10. So that is how this is like, it's going to start, and remaining portion is the MAC address here. So I will explain you this concept of link local when we will try to see the neighbor discovery process of IPv6 address. So these are the three categories of your unicast address. The second category we have is your unicast. We have discussed. The second we have is your multicast. So this multicast is nothing but similar to class D. So I'll write here similar to D class of IPv4. So multicast addresses are also there. So it always starts with FF00. Starts with double F double 0. And I'll put some double colon and /8. So this is the representation given to the multicast IP. And the last we have is your anycast IP, which is a different concept. So let's try to understand this anycast, then we will summarize the three categories of IPv4 once again. So this Anycast IP is something which is used to identify multiple interfaces. Used to identify multiple interfaces, and also it sends the information to whichever it finds first. And sends the info to whichever it finds first. So this is one thing about the Anycast address. Like, let's try to take one example to understand this Anycast IP. So what I'll do is that let's take an example that I am a user. So this is me, let's say, a user connected to a router. Now, this router is further connected to the internet service provider. So this is ISP router. And ISP is further connected to various public servers. So let's say there are three different public servers, server 1, server 2, and server 3. So these are three different public servers. Let's say this user is trying to access google.com. So when the user will try to access the google.com, the request will reach here. Then from the reaching to your router, it will reach to ISP. Now, like guys, when we try to browse google.com, so we all know that Google is not having one data center in the complete world, like in the entire globe. So there are various data centers of Google which are available. Like in our country also, we got 3 data centers. So to whichever the data center the request reaches first, the data center will automatically reply back. So over there, like, in terms of server, if you will go through with the server concept, so you will find that whenever we create data centers, or that doesn't matter if it is an offline or it is a cloud-based data center. So all these data center, all the multiple public servers of Google, they do have some, information like this server will have its own IP, let's say 10.0.0.1. It's having some 10.0.0.2. This server is having some 10.0.0.3. So all these multiple servers have their own identification, but we create one, cluster of all these public servers. And cluster is nothing but in terms of cloud computing or in terms of server, you will find that a group of multiple servers, we call it as a cluster. So to this particular cluster, we will define one thing which we call as virtual IP. And this virtual IP, we are going to consider it as Anycast IP, so that whichever the server, like whichever the public server will receive the Google request for the prior part, then it is going to respond accordingly. So it is used to identify multiple public interfaces or multiple interfaces. And it's going to send the information to all the interfaces, but like not to all the interfaces, but on the specific one, it's whatever it's going to find the public server, like who is nearby or who is going to reply me as soon as possible, like the shortest path concept we can use in here. And also guys, please note this point as well, that the unique local and the global unicast IP, which we have discussed in the category of unicast, can be considered as Anycast IP addresses as well. Now let me just summarize you the three categories of IP v6 addresses which we have discussed. So I'll write the heading IPv6 addresses, IPv6 address types. And in the category of IPv6 addresses, we have discussed three categories. First category, second, and third. The second category is nothing but similar to your multicast. So it's a multicast, and the third category is your Anycast. And the first category was your unicast. So in the category of unicast, we have seen three categories are there. The first one we have discussed was global unicast, similar to your public IP. The second we have discussed is unique local, pretty much similar to your private IP. And we have something we call it as link local. So this link local address is something which is by default enabled on all the interfaces configured with the IP addresses. So when I say unique local, this unique local always starts with FC00 :/7, or you'll find FT00 :/7. And this public IP starts with 2000 :/3, or you may find 3000 :/3. And this link local address, it always starts with the category of FE80. double colon, and /10 is reserved. Rest remaining part is considered as your MAC address. And this multicast address, it is having the range of FF00 colon colon /8, and this anycast address, it basically doesn't have any specific range, but it can be considered, like any IP can be considered as anycast address. So we can make sure this anycast, I'll add one point, that the global unicast and unique local, these IPs can be considered as anycast IPs. So this is what the IPv6 address type is. So I hope everything is clear up to here. No one is having any kind of doubt in this section.
Clear, Jatin.
All right, thank you, Ramesh. So guys, let's have a quick 10 minutes of break, and then we'll try to see the labs of IPv6. So 3 labs we are going to perform. The first is static lab, static routing. The second is with the OSPF, and the third one we are going to see with the EIGRP configurations. So let's have a break for 10 minutes, and then we'll be connecting back in 10 minutes. I'm setting a timer on my screen, so we can connect back in 10 minutes. So we are back with the lab, guys. As you can see here, that I got some pre-configured 2 topologies. The first topology is like the VIOs 3 and 4. In this, we are going to use some static routing. And over here, this area 10 and area 0. This is basically for your OSPF version 3, which is basically all about your IPv6. So I will not describe the complete OSPF because just a quick, introductory part it is. So we will see the OSPF IPv6 and your OSPF sections, but we'll try to see like some basic things in your IPv6. So let's quickly get started with VIOS 3. So as this is my VIOS 3, you can see here, and I'm going to define the IP addresses. So you will try to see enable, and I'm going to show you show IP interface brief. So you can see all the interfaces are unassigned. And also if you'll try to see show IPv6 interface brief. So all the interfaces are unassigned, like all the gig 0001. So I'll quickly configure the devices. So I will say that the interface gig 00 is having the IPv6 address as 2001 double colon 12 colon 12 colon 12. Now this colon 12 12 I can simply write like this as well. 12 0 0 12. So instead of writing 0 0, I'm just using 12 12 12 double colon 1, and the /64 represents the global prefix value, like the network portion we can say. And once this is done, I'll say no shutdown. Exit. Now you will see one thing, and I'm going to verify you do show IPv6 interface brief. Now over here you can see that we got some IP address of FE80, and I told you that FE80 is something which is basically your the link local address, and this remaining part is basically the MAC address of the interface. Now also I'm going to select this gig01 interface, and I'll assign the LAN IP of FC00, this private IP. So I'll say interface gig0 by 1 is having the IPv6 address of FC00 11 colon colon 1/64. No shutdown. Exit. To verify the same, do show IPv6 interface brief. So over here you can see both of the interfaces are up with the link local addresses also there, and the interfaces are up. So I'll define the same thing on the VIOS 4 as well. Then we will perform some static routing after defining the IPv6 addresses here. So I'll say enable configure terminal, and I'll say interface gig00. IPv6 address is 2001 colon 12 colon 12 colon colon 2/64. No shutdown. Exit. So once this is done, the next interface I got is gig01, having the IPv6 address of FC00 colon 22, 22, 22 and colon 2/64. All right, no shutdown, exit. Now to enable the routing here, like as of now, no routes are there. So if you'll try to see, do show IPv6 route. So as you can see, no routes are there. These are the locally connected and directly connected routes which it is showing you. And also if you'll try to run some routing command here. So let's try and see some static routing on the VIOS 3. Now over here, I'll just select the interfaces like, like after defining the IP addresses. Now I just need to enable one command if in case I'm going to define the static routing here, which is IPv6 unicast routing. So I'll say IPv6 unicast routing. So this is the command which you need to enable on both of the devices. If in case you haven't enabled this command, then routing is not enabled for IPv6. So you need to enable this IPv6 routing if you are going to configure some IPv6 routes here. Now to do the static routing, the concept remains the same like we have seen in the IPv4. So instead of saying IP route, you will say IPv6 route. Then you need to define the network which is FC00. Let's say 22 colon 22 colon 22 colon 22 3 times 22. Now double colon you are going to use, and you will not define this dot 2 here, the network ID. So instead of that, you will simply say /64. And the next hop you are going to define is 2001 colon 12 colon 12 colon 12 colon 2. So this is the next hop address which you have defined, and the same configurations you need to enable on the router number 4. So let's try to see from the R4. All right, so this is your router 4. Now I'll say IPv6 unicast routing, and I'll say IPv6 route, and I'll say FC00 colon 11 colon 11 11 colon /64, and the next hop is 2001 colon 12 colon 12 colon 12 3 times colon 12 colon 1. So this is the next hop address for the router number 3, like for the router 4 to reach on this FC11 dot network. Now once this part is done, so if you'll try to ping FC00 colon 22 22 22 colon 2. So you can see the success rate is 100%. And also if you'll try to verify from the VIOS number 3 as well. So do ping FC00 colon 22 22 colon 2. So you can see the success rate is 100%. Also you can verify to show IPv6 route. So you'll find some static entry for the network which you have created here. So the concept for static routing remains the same, and it is saying that I'm connecting via 2001 12 12 12 colon 2. And once this is done, the next thing you can see over here, show IPv6 route static. So you can see only one static route entry is there, having the AD value of 1, and like the metric it is using as of now, nothing. So that's how we are going to perform some static routing. Now once this is done, guys, I'm just trying to turn off these devices because I don't need these devices. Now we will quickly configure this VIOS 1 and this VIOS 2 with some OSPF version 3. Now OSPF comes up with two versions, guys. If you are familiar with that, we have OSPF version 1 and OSPF version 2 and version 3. So OSPF version 3 is all about the configurations which are basically correlated with the IPv6. Now, as we know that OSPF version 3 is basically for IPv6. So there is a difference between the version 2 and version 3, that the major difference is version 2 is going to support the IPv4 address, and 3 is going to work on the v6. But also just one more difference, that the OSPF version 3 runs on the link, like rather running on the subnet. So we don't need to, define some kind of subnets here. So we need to advertise the links here. So how we are going to do that? Let's assign some IP addresses first. So I'll say the host name is R1. Then I'll say interface x00. So I'll say interface gig00 is having the IPv6 address of 2001 colon 12 colon 12 12 colon 1 slash 64. No shutdown exit. And I'm also gonna use the link local address. So I'll say interface gig01 is having the IPv6 address of FC00 colon 11 colon 1 slash 64. No shutdown, exit. The same configurations I'll be implementing on the router number 2 for both of the interfaces, gig00 and gig01. So I'll define the host name is R2. And here I got the interface gig00, and it's having the IPv6 address 2001 colon 12 colon 2 slash 64. No shutdown. The link is up. I'll select the next link, which is gig01, and I'll say IPv6 address will be FC00 colon 12 colon 12 colon 2 slash 64. No shutdown, exit. Now here, this is like the basic set of IP configurations which I have defined on my routers. Now guys, see, as per the OSPF configurations, I got some area 10 and I got some area 20, area 0 as well, because this is something which I got two different areas, and this is an OSPF also which supports multiple areas. So first command, like basically, and I told you that, OSPF in case of version 3 runs on the links, like rather than running on the subnet. So the very first command I'll enable is IPv6 unicast routing. If in case you are not going to enable this command, then your routing is not enabled. Then you will say IPv6 router OSPF, and then you need to define the process ID. So this is the first command. Then see, you will get a log here that OSPF version 3, process version 3, IPv6 could not pick up a right router ID automatically. So now, when in case of OSPF, you are configuring the OSPF with IPv6, so you need to make sure that the router ID you have to configure it manually, and the router ID you can pick it up from the IPv4 address as well. So I'll say the router ID. And the router ID I'm going to use is, let's say, 1.1.1.1. So once this is done, I'm simply going to exit. Now I'll advertise the links here. Like see, in case of normal router OSPF configurations, we will be doing the configurations like router OSPF 1, and then after defining the router OSPF 1, we have to define the network. The second command we use to define like network 0 dot. For example, I got some network 192.168.0, then some wildcard mask, and then after defining the wildcard mask, we need to define the area. So it's not really like the same we have to do in like the normal OSPF, but in case of IPv6, first of all, you have to define IPv6 router OSPF, then some manual router ID you have to define from IPv4. Then after that, you need to advertise the links. So I got the first link as gig01. So I'll say interface gig0/1, and I'll simply say IPv6 OSPF 1, and it's a part of area 10. Exit. And I got interface gig00. It's having IPv6 OSPF 1, and it's a part of area 0. Exit. So that is how the links you are going to advertise in case of IPv6. Then the second thing, you need to go on the router number 2. So here you got to advertise these two links inside the area 0 because these are the parts of area 0. And let me re-verify once again. Yeah, so gig 00 I have advertised in the area 0 as you can see, and gig 01 is part of area 10. No problem. Let's try to see here. So I'll say IPv6 unicast routing, IPv6 router OSPF1. Then it is going to give me the log to configure the router ID. So I'll say router ID 2.2.2.2. Exit. I got the interface gig 0 by 1. IPv6 OSPF. And the process ID, then it's a part of area 0. I got the interface gig 00. It's a part of area 0 exit. So I'll see the log we got in here for the OSPF, and rest everything remains the same in here. So if you'll verify, do show IPv6 protocols. So you'll find that the OSPF1 you are using and the router ID you are using in here is this. And if you'll try to see, do show IPv6 OSPF neighbor. So here you can see 1.1.1 is the neighbor, and it is using the neighbor ID instead of picking up the, the IP address, because IPv6 address can't be picked up in case of OSPF. So that manual configured router ID should be there, and the timers and rest everything remains the same, which is a part of OSPF. Also, you can verify do show IPv6 OSPF database. So you can see some type 8 LSA is also generated, which comes with some, IPv6, but that's certainly not the part of Cisco. So all these things will practically verify when we are going to get more in detail about the OSPF sections. So that is how you are going to see. And if you'll try to run the command do show IP root OSPF, all right, do show IP root on the VIOS 2 from VIOS 1 also. Let's verify. Do show IP root. Okay, let's try and see. It's not giving me any routes, but the agencies are up. If I'll try to ping FC00 :12:12:12:12:2. So success rate is 100%. All right. So these are some point-to-point links. That's why it's not giving me the information. So that is how, guys, you are going to configure. And the same scenario implies with the EIGRP as well, that you need to enable the IPv6 routing, then defining the EIGRP process. And then after you need to advertise the links. So this is something we have in case of IPv6 whenever we are doing all these basic set of configurations for OSPF, or we can say for your EIGRP and the static routing. So all these things we will practically see more in detail when we will move towards the OSPF and EIGRP section. But that is just an introductory part for your lab section. So I hope everything is clear up to here to everyone. All right, everyone. So let's try to see some layer 2 options for the IPv6 now. So let me share my PowerPoint screen with you for that, because some basic theoretical part is there to discuss for the IPv6 layer 2 options, and then we'll see what else is the next thing. So we have discussed the IPv6 introductory part. Now some advanced things which are basically the part of your NRC training. So we'll start with IPv6 layer 2 options. So I'll say IPv6 layer 2 options. Now, what are these IPv6 layer 2 options we are going to see? So what exactly in this section we are going to see what exactly the duplicate address detection is. We call it as DAD, and some neighbor advertising messages and some neighbor discovery process. So let's try to, take one example to understand this scenario. I got two devices. This is my router 1. This is my router 2. Both of the devices are connected with each other. So let's say there is some IP address as of now I'm just implementing. So let's say some IP we are going to have in here is some 2001 :12 ::1. So once you are going to enable this IP address on this router, there will be definitely some MAC link local address. So let's say along with this IP there will be some FE80::1. So this will be some link local address which is going to come up. And once you are going to execute some IP on this device as well. So let's say over here you have executed 2001 ::12 :2. Then also with this IP you are going to get one link local address. So which is FE80::2. So this address you are going to get in here. Now let's assume that some MAC address will also be there. So let's say that we got some MAC of 0000.1234.1234 and also some MAC address I'm going to assume here 0000 and 4 times 2 I'm going to get in here. So this is something we got in here, and normally guys, see what happens when you connect any new network segment on any of the device with the IPv6 entry assigned to it. So it can be a local link local address on a normal IPv6. So definitely there will be one link local address which will come along with the IPv6 enabled interface, which I have already told you. Now, once you are going to enable this thing, it's going to send a request on the link and on the same network segment. And in that request, like when you are going to enable this IP, let's say you have given this 2001 IP normal IP address on this particular interface. So it is going to send one request to ask that is there any other node using the same IPv6 address, and after a specific amount of time, if no host is going to reply, it is going to consider it as a unique IP and then it is going to add that IP automatically to that particular interface. So this is something we have in here. So whenever you are going to assign the IPv6 address, so it's going to perform some DAD, which is duplicate address detection. So where any link local address like an IPv6 we can say is verified before it assigns any specific interface. Like if the node is using some IP, then the node will return a neighbor advertisement message that contains some tentative local address information. To verify, you can use some debug commands as well. And like there are some messages as well, which I will explain you. So when it comes to the layer 2 options, all these things practically I'll verify you. Now there is something we call it as NDP in IPv6. So this NDP stands for Neighbor Discovery Protocol. So this neighbor discovery protocol is something pretty much similar to ARP, which resolves the IP to MAC and it uses some broadcast to find the MAC, right? So in case of IPv6, instead of having ARP address resolution protocol, we have this NDP. We call it as neighbor discovery protocol, or we can call it as neighbor discovery process. So it is going to use two different types of messages. Uses two different types of messages. Now, what are the two different types of messages it is going to use? The very first we call it as NS. NS stands for neighbor solicitation. And the second message it is going to use is NA, which is neighbor advertisement. Now, when I say neighbor solicitation, so this neighbor solicitation is nothing. Let's write on the next page. So NDP uses, I'll write this point. Neighbor discovery protocol uses two types of messages. And what are the two types of messages it is going to use? The first it is going to use is neighbor solicitation, to which we call as NS, which stands for neighbor solicitation. And this neighbor solicitation is nothing but it requests a layer 2 address information. So I'll write here request a layer 2 address information. So this is one thing. The second thing we have is NA, which is neighbor advertisement. Now this neighbor advertisement is nothing but it is the reply of the layer 2 information. The reply of L2 information, which is requested by the neighbor solicitation message. Now let's take that simple example previously, which we have taken in that I got 2 routers here. Now, similarly, if the switches don't identify the IPv6 address like the way switches normally don't work on the IPv4 address as well. Switches are going to use some kind of MAC addresses to verify and to figure it out that which are the connected client machines, and for that it is going to use some neighbor discovery process. Like here I have defined these things. Now, before it is going to send some kind of messages, like there are some messages which are basically being verified over here. So let me show you the same thing on the lab screen. So just let me share my lab screen. Raghu, it's not the unlicensed version of EvenG, it's the community version of EvenG. So it depends on the requirement, like what is your requirement and what is the resources you are using in your machine for the EvenG. Now guys, here you can see these are my 2 routers and I'm going to turn these devices on and let's try to see some basic things. So I'll open both of the devices over here and here as well. So let these devices turn on. Meanwhile, we can wait for a sec. And I will also verify you these messages which IPv6 is going to generate. So as you can see guys, my devices has now started. So let's wait here and then we'll re-verify all these things once again. So this is my VIOS 2 guys, as you can see over here. So I'll be implementing some commands on the VIOS 2. And also this is my VIOS 1 CLI screen. So I'll just change the configurations like hostname and all these things. So I'll define the hostname as R1. And this is my R2. Now I'm just going to enable one command here. So I'll simply say env and I'll say debug IPv6 ND. ND means neighbor discovery. So the neighbor discovery events are turned on in my VIOS 2. Now guys see, over here I'm going to define some IPv6 address. So I'll say interface gig00 having the IPv6 address of 2001:12:12:12:12 2/64, and I'll say no shutdown. So you can see guys over here, like once I have allocated, you can see that once I have enabled, just let me undebug all, exit and you all. So I have turned on the debug command, but let's try to verify the outputs when I enabled the debug command. And over here you can see that the IPv6 address and some prefix of this address was active and the state is not ready, and then it performed some DAD. So this DAD means duplicate address detection. So now that in the duplicate address detection request, it is trying to generate one linked local address with FE800::1 on this particular interface. Now with this duplicate address detection for FE80, it's going to verify that is there anyone inside the network who is using this linked local address which is FE801. So it got the reply that no, it's the unique address, no one is using the same address. So I'm going to use this, and then after doing this allocation, it has allocated this particular interface with this duplicate address detection. And also here you can see here the duplicate address detection was completely done for this particular address, and it was sending some duplicate address detection neighbor solicitation message. So I told you that it's going to use two types of messages. Solicitation is for requesting a layer 2 address information, and then after resending the neighbor solicitation message, it just receives some neighbor advertisement messages, and that is how all these things are going to work. It's going to use two messages. One is the solicitation, which is for requesting the layer 2 information, and neighbor advertisement, which is for replying the layer 2 information. And also it's going to perform the duplicate address detection to check is there anyone inside the network who is using this address or not. So if you'll try to see show IPv6 interface brief, so you can see this is the link local address which it is using, FE805200 FE002. You can verify in the debug output as well. Okay, yep. Here you can see IPv6 neighbor discovery gig00 having the link local is FE805200 FE020. Lastly, its link local is up and all the duplicate address detection is turned on. Now also I'm going to enable the same command here, debug IPv6 ND neighbor discovery. Now, if I will be implementing the IP address on the VIOS1, you'll find some messages here on the router 2. So I'll simply say interface gig00, I guess. So I'll say gig00 IPv6 address, and the address we got on the router 1 is 2001 colon 12.12.1/64. No shutdown. Now on the router 2, you will find some messages which are basically being generated. So you can see over here, some neighbor discovery was done in here, that it was sending some, it received a neighbor advertisement message because solicitation was generated from here, from the router number 1, because it was requesting. Now it received a neighbor advertising messages, and then after receiving the neighbor advertising message, it has just performed the link local and duplicate address detection here. So we can run the same command on the router 1 to verify once again about all these types of messages: neighbor advertisement, neighbor detection, and neighbor solicitation. So these are few things which you need to understand. And also, whenever we are trying to say that in case of IPv6, switches don't really identify the IPv6 address, so there should be something to resolve the IP into MAC. So it is done by this NDP. So when we say about this NDP and in the previous output which we verified, so before the PC is trying to send some kind of message, it is going to generate one ICMP message type, which is, I guess, 135. Let me try to see the output of VIOS2. ICMP v6. ICMP neighbor discovery. All right, no problem, guys. See, like whenever you are trying to do the IP configurations and whenever you are trying to enable the IP configurations, so the one ICMP message type for IPv6, it is ICMP type 135, which is being generated, where it says the source IP address will be the IPv6 address of the device. And after that, the destination will be a solicited multicast B, which is like the default address. If the devices are in the same network segment, then they are going to join a specific group address, which is, we call it as multicast address. Then after joining that multicast address, we also call that address as solicited node multicast address. And this is something which we can verify by using the show IPv6 interface brief command, which we have already seen in the lab. And now once the solicited message is generated, there is the MAC address of the device, which is going to send the request to the particular host or to the group address, like what will be the particular MAC for this device for the resolution. Can verify that it is the unique address which I'm using. And this is how the link local address will be coming up. You can see I requested for the DAD, and then the DAD was come up and it's having the link local address in the upstate. And also all the messages type, you can see try to sending the DAD neighbor solicitation message, that I'm sending duplicate address detection for the neighbor solicitation to resolve the MAC. And then also it was sending some neighbor advertisement. and all the information it is being sent, and after sending the DAD neighbor solicitation and advertisement messages, it is going to come up that no one is using the same link local address. So I'm good to use this address. If in case any other device is using the link local address, it is automatically going to detect that this link local address is basically not being used in here. So let's try to see one more thing. So I got some link local address of FE80. All right. Show interface cake00. Oh, this description summary. All right. Show IPv6 interface. Show IPv6 interface cake00. Now over here. All right, no issues, guys. I'm not getting the accurate command to verify that particular thing. So I'll just reshare the same with you, everyone, tomorrow. So that is it for the neighbor discovery process, and that is how the neighbor discovery process is going to work in case of IPv6 addresses, and that's how it's going to generate three types of messages. And the very important thing about the V6 is like the NDP process, where it's going to perform some neighbor discovery using the DAD and with the help of NS and NA. These are the two types of messages which your devices are going to use. And also you can try the same lab at your own elsewhere and try to verify the debug output and try to see that the messages which it is going to generate. So this is one thing, and I hope it's pretty much understood to everyone. You are not having any kind of doubt, and if you do have any doubt, so you can let me know now, because from my side I'm done for today's session, and that is it we are going to discuss in today's session.
Hello, Jatin. I have a doubt here in this.
Yes, you can share your, that's the loopback address must be configured on IPv6 router. You are mentioning the loopback address, which is basically like the normal loopback we created in the IPv6 as well, right? In the IPv. Okay, so we can consider that as well. But like, in case of loopback addresses, I will be able to see that, I guess, the neighbor solicitation and advertising messages. But yeah, you can configure. It's not like that you can't configure the loopback. So you can go with the loopbacks. Any unique local range you can select for loopback ranges as well.
No, my question is it mandatory to have that all the time?
No, it's not really mandatory, but yeah, just to show you, I have, see, in the last lab when we were discussing about the NDP process, so I only used the 2001 IP. I didn't use any kind of loopback scenarios. So just for testing purposes, these addresses are used. It's not really mandatory. So that is it for today's session. And I guess Ramesh even see lab, so we can have the lab resolution. So you can share your screen and you can show me what queries you are facing or any queries anyone else is having. So please just let me know.
Jatin, are you able to see my screen?
See, I've shared your screen, but it's not visible. Just only blank screen is visible to me.
Okay.
Yep, now it was visible.
Oh, sorry, I stopped again.
No,
1 minute.
no
Give
problem.
me a moment. Now,
Yes, now it's visible. So go in the edit virtual machines. Go in the processors. Just check on this virtualize Intel VT option
yes.
and click on OK.
Okay.
Now try to turn on your virtual machine.
Like this, it is coming.
Okay. So I'd like to see this error usually comes when your virtualization is disabled from the BIOS settings of your device. The screenshot which you shared with me was a valid screenshot, but
Yes.
yep,
Here you can see. Actually, I have checked here itself. You are able to see here, right? Virtualization is enabled.
virtualization is enabled.
Here, down. I'm not able to
Okay,
hide.
just try to just turn off that settings once again. The virtualized VT Intel option.
I have to turn it off, right?
Yep, just uncheck this option. Click on OK. And now try to turn on your VM machine.
No, still the same issue.
Then for sure, it's just about the virtualization. So you just try to open your BIOS settings while you restart your laptop because it's some issue with Windows 11 OS as well. So you can try to see in the official documentation. So which laptop you're using? HP?
Dell.
Okay, so you can check in the Dell BIOS machine. So is your virtualization is enabled in the advanced settings? So because
Okay.
usually, the same issue was happening with one of the participants because he was also showing the same thing that virtualization is enabled in the task manager, but it was really not enabled. So you can try to check that. And if in case it's still not working, then I'll schedule one call with our tech team. So they will
Okay.
resolve the same issue.
Yeah. Okay. Okay, Jen. Thank you.
So I hope everything is clear to almost every one of you. You guys are not having any kind of doubts. Any doubts still you have, you can let me know. Meanwhile, I'm sharing the notes in your Telegram group. And I guess everyone has also joined the Telegram group. And all the notes and the lab guides for the labs we are going to share in your Telegram group. So you can consider the notes and the lab guides or any other required resources if you require. So you can let me know. So I'll share those as well. So guys, I have just dropped the notes in your Telegram channel. You can go through with the notes. Any doubts, any queries you guys have in the topics which we have covered up today, you can just ping me on Telegram anytime. And that is it for today's session. And I hope you find it useful. So that is it. So thank you for joining, guys. Let's connect tomorrow, same time. And the topic for tomorrow, we will be discussing some first hop security features for IPv6 and some DHCP concepts with IPv6 as well. So that is it for today. Thank you for joining, guys.